In the last video, we have seen how an output is generated when an input is given to an LLM. Today, we are going to see the internal architecture of the LLM, how it functions exactly. This is how the internal system of an LLM look like, how the data flows from tokenization to embeddings to positional encoding and self-attention, and the feed-forward neural network, layer normalization, the clustering which occurs along with the linear normalization and linear logic and the softmax function. Coming to tokenization, the word tokenization means the division of entire sentence or word into chunks of data. We think that each word is considered as a token, but it is not necessarily like it happens in the background of LLM. Suppose we have taken here example of necessity is the mother of invention. I hope everybody can understand how the tokens are divided, because necessity is a single word, but it is divided into multiple tokens here. So we cannot guarantee that a single word is a token. Here are a few things we need to understand. Do LLMs understand the text? No. And token is a complete word. Of course, here is an example. How does the identification of token happens? With the generation of token IDs, it identifies each character or set of characters as a token. Here is a small glimpse of how tokens are generated in for a sentence. This is for GPT-3. You can see I have written the text. This is the number of tokens, 47 tokens and 216 characters are there. This is the text, how it is converted into tokens. And when it comes to selection of GPT-4 model, the same text have different tokens and different characters. And the token numbers are also changed. And when we select the GPT-5, it has a different set of tokens, 52 tokens. And this is the thing, how tokens are generated and changes from model to model. Next one is vector embeddings. The vector embeddings means the generated tokens in the previous stage are converted into the vectors, which are called the embeddings, because machines cannot interpret text. That generated token is converted into the vectors. Vectors are always a floating point numbers. The distance between two vectors is the measure of the relatedness of one word with the other word. And small distance between they are highly related to each other. And if there is a larger distance between two words, they are not much related. The relatedness is measured by cosine singularity, and it is having a range of -1 to 1. And if the distance between them is need to be measured, the cosine distance measures the distance between them. And coming to the next one is the positional encoding. The positional encoding is necessary because whenever the transformer takes the multiple vectors and the multiple vectors goes through multiple stages of processing, they does not maintain the order, since the embeddings simultaneously takes up in the multiple stages. So we need to maintain a position. Suppose, for example, dog bites man is different from man bites dog, because the entire meaning gets changed. So we need to maintain the position while the result is displayed. So to fix that, we need to inject a sense of order for the positional encoding. For each token, the position of encoding is calculated by this function, cos of position of the word in the sentence or a letter in the sentence by 10 power 4 power 2i by d of model. That I refers to the specific dimension index. This is embedding, right? So it has a certain dimension and certain position. Based on that position and based on the index, we need to calculate the position embedding and uh, perform the element-wise allocation of positional encoding for each element in the text. Means for every element in the text, you need to calculate the positional embedding. Coming to next one is self-attention. This is the important mechanism of transformer model. It indicates the meaning of each word and measures the relativeness of each word with other word. The identification of these lines indicates it is just displayed here to illustrate each word relates other word. The tokens are displayed along with the vector embeddings. The similarity is found out by cosine similarity, that is through this formula. If there is this is one vector and this is other vector, the two vectors have similarities or distances because in each vector there are multiple words, characters, everything, and one word has to be related to other word to keep the context of distance or similarity. Two vectors are 90 degrees apart, means their score is 0. They are not at all similar and they are not at all not similar also because they have no relatability. When they are exactly opposite, means they are exactly located in the different planes or opposite directions. They are not at all similar. And coming to feed-forward neural network. This is the important block. Like it is a mathematical function that having the linear transformations. Like you can see the function. X is the context-heavy vector. Means after the positional encoding happens, the vector passes through the multiple stages within the transformer. While the vector is passing through multiple stages, we need to preserve these things: word embedding and positional encoding and the attention output. These are the three stages we need to preserve. Once these are not mathematical addition, but these are considered can be like positionally added. W1 and W2 are the weights generated through the training process. W1 acts as an expansion matrix, which is called as concept detector. The concept detector means when a text is processed, it detects whether it is related to a bird, a fruit, a food, or a medicine, or a passion, or an feeling. These are the things the W1 detects, and P1 acts as a learned threshold, shifting the sensitivity of each single concept detector. Means it shifts the dimensional quantity of the W1. And the activation function. Activation function is this maximum of 0 comma x of W1. What happens here is during the filtering function, some of the words which are not related to the meaning of the context are nullified because their intensity will be negative and it can make the model unstable. So uh, the information may be lost even when some texts are made 0. So to preserve that information, again W2, which acts as a compression matrix, it acts as a concept synthesizer also. It also checks what is the information that is missing due to the nullifying of these negative terms. It helps in getting back the information. And next one is layer normalization. Layer normalization happens at the multiple levels of information processing in the transformer. That is, for example, we take, I wish to have food here near the dash tank, enjoying the beach view. Here, the important keywords are food, bank, and the beach view. The food indicates directly to the dining or restaurant because there is a beach view. There is a bank also. Contextually, it can shift the edge of water because the beach highlights the bank here. Which type of bank it can? It can be a river bank or it can be a savings bank, which we use. But the beach context here signifies the river bank. Enjoying the beach view, it strongly connects the seaside of uh, nature part of the environment. When the context heavy vector, which we have discussed in the last screen, that is x, is added to the original vector, the values of dimensions become very extreme, like the water, the water which can be related to the beach or nature, it spikes to 50. The value gets spikes to 50. And the finance or urban, which is related to the bank, that gets dropped to 40. The disadvantage is extreme spike in W1 matrix. The matrix multiplication will result in the high values so that they essentially defeat the network from self-learning due to variation of limits, that is in the W1 from plus 50 to minus 40. The self-learning mechanism of the LLM will get unstabilized. So to avoid this, the layer normalization is necessary. How the layer normalization calculates this? First one is it calculates the mean and finds the variance. Then it subtracts the mean from each value and divides it by the variance, then impact. It scales down to a marginal values like the plus 50 is brought down to 1.5 and the and the finance value is brought down to 1.4. Finally, we can see the linear logic function and the softmax function. The information is processed to linear logic function. It is similar to a layer normalization function, which happens in the transformer, but the linear logic function happens outside the transformer model. The raw scores of how each word is defined in dictionary are defined here. It is, you can consider like linear logic is the gut feeling of transformer. Logics have no higher limits. These are the things where the limits are not there. In the first slide, we have seen because the token IDs, how the token IDs are generated. Similarly, the logic also have no higher limits. High logic score of a word defines the predictive winning of the other words. Like we have seen the final decision. The logic for river is 12.5 and logic for bank is 11.2. Seems that the bank is relating to the river. So the river is the predicted winner. Here, linear logic makes the prediction of a winner, not the exact word that gets in the output. The softmax function. It is an exponential function that turns every negative number into positive words. It converts the logics into percentages. Even in the logics also, we have some negative numbers. So to avoid this, we have the softmax function. It generally it is an exponential function, so it converts the even negative value gets converted into positive value with a minor decimal points because it forces sum to 100%. Like the multiple logics are get converted into percentages. So the overall percentage is 100 and it creates a clear winner. Model becomes the statistically more confident about the best. Here the model is predicting, but here the model becomes confident after getting calculated the statistical numbers. The last one is the selection. How the selection process happens. Multiple algorithms are used in the selection process like decoding algorithm and model selection. Model selection mainly depends upon how we choose an LLM to perform a specific task. These are the different algorithms. Greedy algorithm, temperature selection like low T and high T, and top K sampling and top P nucleus sampling. Greedy algorithm. What does greedy algorithm mean? It selects the token with the highest probability. And token selection. In this, the parameter that adjusts the probability distribution. Low T makes the model more confident about the logic. Like lower temperature value makes the model more confident about the logic. And higher temperature value makes the model more creatively thinking about the solution. And top K sampling means model restricts most K next solutions that redistributes the probability among them. Like if there are 100 values in the sampling process, it takes the most 10 values which distributes the probability up to the 90% or 80%, which defines the highest probability you can think of that. Top P nucleus sampling. This means more dynamic approach than top K. It is more dynamic than top K because it selects the smallest set of tokens where cumulative probability exceeds the threshold P. If P equal to, for example, we will see if P equal to 0.9, the model considers only top 90% of probability mark. This allows for more flexibility in the context where more words are equal likely. Means it figures out the most words which are more likely to each other and more precision because you can use any word in that context. These are the things that happen to select a word. This is how the LLM predicts the next word and generates the output. Based on the type of LLM, the choice of algorithm is also there. Right now, these are the algorithms we use. And right now, Claude Code has been using top K sampling and top P sampling. And various other algorithms are used by Gemini and ChatGPT also. This is the thing I want to share with you. And if you have any things more on LLMs, you can please reach out or please share your learnings in the comments. Thanks for the opportunity. And I hope you have learned a few things from this. Do share me your feedback on this. Thank you.